Hello everyone. We're moving on to question 2 on your Excel homework for chapter 6, bond valuation. This example it requires more work from you, but those are simple calculations. And hopefully by the end of this example, you'll feel comfortable with valuing bonds in Excel and on the calculator since they're very similar. The point of this exercise is for you to calculate prices of 4 different bonds as the prevailing interest rates change. You have 2 coupon bonds with different maturities, and you have two zero coupon bonds with different maturities, and you have 2 coupon bonds with different maturities. The point of this exercise is to illustrate the very important properties of bonds. One being prices are inversely related to changes in interest rates. So as we value these zero coupon bonds, we will notice how with the decrease in interest rate, the price of the bond should go up. What is more, as the maturity of the bond increases, the bond with higher maturity, meaning the payment of that bond is going to be later, is going to change in value more. It's going to be more volatile. Next, we're going to look at bonds that pay coupons throughout the life of the bond. Here, we should also notice an increase in price with the change in interest rate, but that increase in price is going to be less than for the bond with no coupons. And what is even more, the bond with the higher coupon will have a less increase in price. Okay, so the price will be higher than the zero coupon bond, but the change will be smaller, and you will see that we'll calculate change in bond prices. Okay. All right. Here you have tips for how to calculate bond prices and changes in bond prices in percents. Okay, so let's go ahead and get started. We have a tip here, a comment, a positive value is expected. So we're going to start equals negative present value. My rate is going to be my YTM. And your bonds have these tips here. Price of bond A number 1, price of bond A number 2. Number 1 corresponds to YTM 1, number 2 corresponds to YTM 2. So I'm going to put rate 1. My end pair is going to be my maturity. And in this example, for zero coupon bonds, we assume annual compounding, so we don't have to adjust maturity. And because we want to compare apples to apples, the coupon bonds will also have annual compounding, so 1 payment per year. Okay, so end pair is 12. My payment is going to be 0, so I just put in 0. And future value is going to be 1,000 for all of the bonds. Okay, so the value of this $1,000 bond is $397.11. Okay, that is quite a steep discount from 1,000, but this is because this bond is trading at is going to pay back the future value or face value in 12 years, and it pays no coupon to amortize it. Okay, so price of the bond A, so same formula, but here the rate is going to be different. It's going to be the second rate. Okay, so because my interest rate decreases from 8 to 7, I should expect an increase in this price. So I'm going to say equal negative present value, rate will be 7, and everything else will be the same. My end pair will be 12, my payment will be 0, and my future value will be 0. You can ignore the type. If you don't put in the type, it's going to default to 0, and which is what we're doing. Okay, so notice how this bond price increased. It increased as expected because the interest rates went down. Now, the change in bond price is going to be the new price divided by old price minus 1. Okay, you can also do a different formula, the more standard formula, the old price minus the new price minus old price divided by old price. The thing about it, however, is notice how the number is the same, right? It's the same formula. Just the first one I used, and I'm going to keep using throughout this example, is just a little bit more straightforward. Okay, so the price increased by 11%. Let's see what happens, how much this price is going to increase for a 10-year bond instead of a 12-year bond. And I will tell you right now, because of convexity and because of how shorter term bonds will be less volatile, we should expect this change to be less than 11.8%. So let's go ahead and give it a try. So rate will be again 8% for number 1 for the first case. My N now will be 10. So this is my second bond. My payment will still be 0 and my future value is 1,000. Okay? So now notice how the price of this bond is higher. There's fewer years. You have to wait less time for the final payment. Let's value this bond at 7%. Okay, so it's my end pair will be 10, my coupon will be 0, and my future value is the same. All right, so we're comparing all the same type of bonds. Notice here, the price of my bond increased. Let's see the magnitude of that increase. So the new price divided by old price minus 1. See? The bond increased in price, but by less than the longer term bond. This one is less volatile because it has less time to maturity. Okay, now bond C. A few of you asked me, what is coupon bond C? This example should be coupon of bond C, or coupon comma bond C would be less confusing. This just is referring to coupon of bond C. Okay, so it's called calculate coupon of bond C. So I'm going to take coupon percent or coupon rate of bond C and multiply it by face value. There I have it. That's my coupon. Let's value bond C at the first interest rate. So negative present value. So my first rate, right, 1 to 1. End pair is bond C has 12. Payment is the one that you just calculated. And face value is 1,000. Okay, so you see how this is bond C. It has 12 years to maturity like bond A, but the value is higher because it has these coupon payments. So let's see this bond value at the new rate. Payment is this, and future value is this. Right, verify 12, new value. All right, now my coupon, my value of this bond is even more. So what is the change in this bond's price? The new price divided by old price minus 1. See, this coupon bond, even though it had a longer maturity than bond B, it decreased and increased less in price. This is because it had that coupon to insulate it. It's less volatile. Now, I will say that this bond with highest coupon and shorter time to maturity will be the least volatile. Let's give it let's check this out. Coupon of bond D is going to be my coupon rate times my face value. The price of my bond will be present value. The rate will be my first rate. End pair of bond D is 10. Payment is going to be my payment I just calculated, and future value is what I got there. All right? So now this bond is trading at premium. All the other bonds were trading at a discount. This one is trading at premium because the YTM is 8%, but the coupon is 12%. So the coupon, your coupon payment is more than the prevailing interest rates. All right, and last but not least, the coupon bond D with new interest rate. Okay, and let's see how this changed and the magnitude of change. So it's the new price divided by the old price minus 1. Notice how this changed the least. This is because it's the shortest maturity and the highest coupon. Bonds with shorter maturity will be less volatile, and bonds with higher coupon will be less volatile. All right, I hope this was helpful. Good luck, and let me know if you have any questions.